In this video, we're gonna discuss how to make to use frequency distributions to make probability statements. So let's say that we uh, contacted the admissions office and requested information about students enrolled in a college and the number of years that they spent in college. We received a um, data for 100 students. Okay, and so for then we made a relative frequency distribution where we have the number in college recorded and then the frequencies. And then we also figured out the relative frequencies. So by this time, guys, you probably know that we could use a relative frequency as a probability, right? So the probability that the student will spend between 0 and 2 years in college is 0.27, and the probability of 2 to 4 years in college is 0.42. So let's label those events. So an event that the randomly selected student, and that's going to be our experiment selecting one student. Event Y1 would be that the student spent in college between 0 and 2 years. Event Y2 would be that the students spent in college 2 to 4 years. Y3 is 4 to 6, and Y4 6 plus. What are the simple outcomes? These are the outcomes. And these outcomes basically defined by the formatting of the table. So if we are making the table ourselves, you should think of the types of the outcomes that you want to have when setting up your table. Now, also all of these outcomes, they form the sample space. Now, let's talk about what kind of events we can find the probabilities of. I'm going to give you a few examples. So let A be a randomly selected student, event that the randomly selected student spends 0 to 4 years in college. Use a Venn diagram to represent the event A. So 0 to 4 would include between 0 and 2 and 2 to 4. So that would include outcome Y1 and outcome Y2. So the probability would be basically a combination of these two. So we're going to say that the probability of event A is 0.27 plus 0.42, which will result in 0.69. So we added the probability of event Y1 and the probability of event Y2 to get our probability of event A. Okay, question B. Let B be a randomly selected student who spent 2 to 6 years in college. Use the Venn diagram to represent event B. So where do we have it in our table? 2 to 6 would include 2 to 4 and 4 to 6. So those are events Y2 and Y3 combined. So the probabilities of those events are right here. All right, so the probability of event B would be the probability of outcome Y2 plus the probability of outcome Y3, which are 0.42 and 0.20. So we're going to have 0.62. You guys don't see it. So here it is. We already talked about how event A is the event that a randomly selected students spend between 0 and 4 years in college. And here's the representation of that event. We have two outcomes, Y1 and Y2. Now let's see represent not A or the complement of A. So that would include the rest of the sample space, which would include events, outcomes Y3 and Y4. So this is our C, which is not A. And this right here is A, event A. Okay, so there are two ways we could find the probability of event C. First of all, we could add all of the rest of the probabilities, right? We could actually include the probability of outcome Y3 plus the probability of Y4, which are 0.2 and 0.11, and that will give us 0.31. Or what we could do, since we already know the probability of event A, we could just subtract it from 1. So 1 minus the probability of A, which was 0.69, and the result is going to be 0.31, same exact as what we found earlier. So two ways to figure it out. Basically add up all the probabilities that are not in event A, or just subtract event A from a total of 1. Now this line, this row is our totals. It's not included in a sample space. Let's take a look at a couple other statements. So again, we have event A, that a randomly selected student spends 0 to 4 years in college. And we already said that that would include outcome Y1 and Y2. Okay, so that's our event A. And event B is a randomly selected student spent between 2 and 6 years in college. So that would include events or outcomes Y2 and Y3. That's our event B. And this is our Venn diagram. Now let's use that Venn diagram to answer these questions. Question A, represent event E, which is A and B, and calculate its probability. So event E is basically, and means an overlapping of A and B. So that would be our outcome Y2. And so the probability of event E would be the probability of Y2, which is 0.42. All right. Now, if we could also use a formal addition rule. Sorry, that's for the or, not for the and. Okay, so let's go to the next question. Question B, use Venn diagram to represent the event D, which is A or B. So event D, basically it's a union, right? Or means the union of A and B. And that would include all of these, all event A and event B together. So that would include outcomes Y1, Y2, and Y3. So to find the probability of event D, we have to basically add the probability of y1, the probability of y2, and the probability of y3, which will be 0.27 plus 0.42 plus 0.20. And when we add those together, we will get 0.89. Okay. Now here for probability of event D, we could have gone with the addition rule because we already calculated the probabilities of event A and probability of event B earlier. Let me remind you the rule. It says probability of A plus the probability of B minus the probability of A and B. Okay, so we already have the values for the probability of A and the probability of B. So that's 0.69 and 0.62. And then we have to subtract the probability of A and B, which we just found right here. That's event E, minus 0.42. And when we put it in the calculator, we will get the same value of 0.89. So two ways of calculating that probability using the table visually, kind of like intuitively, put them together, calculate. So that's going to be the event calculated together, or use the formal rule. Just the formal rule would be very useful in the case when the table is not given to you, but only the probabilities are given. Then you must go by the rule and use the rule instead of the table.